There is only one reason to use assets, plugins, libraries, or any other third-party package or service, and that is to save time. Which is a very big benefit, but one that comes with the drawback of introducing an external dependency into your project. Which means if it's closed source, you have almost no control over it and are at the mercy of the original developers to fix bugs and maintain it. But even if it's open source and completely customizable by you, you'll still probably need to spend a lot of time understanding its features and figuring out how to add any custom functionality you want. So the question then becomes how to decide when to use a third-party service and when to roll your own custom solution. To help answer this question, I've split things up into a pyramid from bottom to top, where the assets at the bottom give you the most bang for your buck. Using these assets and third-party services saves the most amount of time, are generic enough to have high utility and flexibility, and therefore make the most sense to use instead of building your own solution. While at the top we have the more niche assets that you'll only use in very specific situations. So starting at the bottom, we of course have our main power supply, aka electricity. Setting up your own source of electricity is pretty unnecessary and doesn't really come with a lot of benefits. If you're environmentally minded, you could probably stick a few solar panels onto your rooftop, but at that point I'd call it a day. Going any further would require a significant amount of capital investment, and given the economies of scale around power stations, would require you to sell most of the electricity generated for at least 10 to 15 years before reaping any real benefits. So I'd summarise the pros of rolling out your own solution at this level as it might make you feel better, and the possible upside of being able to cut off your neighbour's electricity at will, while the cons would be everything else. The next tier up on our pyramid, we have the hardware required to develop your game, website or service. Establishing your own mining operation to extract the necessary raw materials, setting up a production facility to refine them, and then soldering them together to construct your own custom graphics card is probably slightly cheaper than buying a 4090 right now, but the amount of time this would take likely outweighs any monetary savings. So again, rolling your own solution at this stage is probably a bit premature. The next step up from hardware is of course the software you're going to be using to build your project. This can be split up into a few sections, so we'll start with the most fundamental, the operating system, which is responsible for interacting with the hardware components you may or may not have built in the previous stage. Now, when developing projects, it's important to try and minimize scope creep, which occurs when you continually add new features, ultimately delaying your time to market. This is especially important when working alone or within a small team, and developing your own operating system would likely be classified as scope creep. Therefore, I would generally advise using one of the existing mainstream operating systems. The next stage of third-party packages you might use comprise the main tools necessary for building out your project. For video games, this would involve software for 3D modeling, code editing, music composition, 2D art creation, and so on. In most scenarios, these are the packages that are used to create the things you'll be putting into your game, and so building your own solution for this is somewhat unnecessary. However, there are some distinct advantages at this stage of not relying on third-party services. For example, developing your own 3D modeling software may actually save time in the long run, as you could almost certainly design a more intuitive interface than what we have in Blender and Maya. Additionally, building your own IDE instead of using a Visual Studio may save you having to upgrade your RAM, as 90% of your memory will no longer be used trying to type out some text. And finally, developing your own texturing and digital art software will allow you to avoid using Adobe products. The next step up in the pyramid covers the engine and programming language used to build the final product, in this case, a game. Back in the day, it used to be somewhat common to see teams using their own engine and perhaps an in-house scripting language to develop their games. However, this has become less common due to the widespread availability of two 3D computer graphics engines, namely Unreal and Unity. Given the flexibility of these two engines and the increased complexity of modern 3D games, many developers now opt to use either Unity or Unreal to save development resources. And because Unreal uses C++ and blueprints while Unity uses C# for game code, custom scripting languages have become less common as well. Nowadays, using a custom engine or programming language is almost exclusively the domain of huge game companies like Nintendo, EA, or Jonathan Blow. The final area of the software stage in our pyramid is the use of middleware in development. These are packages that are imported into game engines to handle areas common to most games. For example, Fmod for audio, Havoc or Physics for 3D physics, Steamworks multiplayer for networking, and so on. It's often advisable to use middleware in these areas because of how generic these parts of games are. However, this is also an area where many developers still build something custom specifically for their game or engine. For example, in my last game, I wrote my own networking solution instead of using a third-party networking library like Steamworks. The benefit of doing this allowed me to control every single byte of data sent across the network and provide cross-platform multiplayer. The downside is that it took me months to get it working, and optimizing bandwidth and cross-platform gameplay doesn't really mean much when no one plays your game. The final area of the pyramid is where the decision between using assets versus going custom becomes an even harder decision. At this stage, most of the generic functionality needed to develop your project is already being used, and what's left are the areas of the game players will directly interact with. Therefore, a common concern among new developers is that their games will be labelled as asset flips by players if they use anything bought on the Unreal or Unity stores. But this concern is somewhat misguided since you're never going to actually finish your game, so there isn't going to be anyone around to call it an asset flip. Regardless, the best advice I can give for deciding when to rely on assets and when to build something yourself comes down to two things: how significant it is to your game and how custom the feature needs to be. For example, if you need a generic day-night cycle that doesn't need to be customized specifically for your game, it makes sense to rely on a third-party asset. If your game is going to have very standard character movement and cameras, then there isn't a lot of downside to using a simple character controller asset and the built-in camera package. If you don't have a super specific visual style for your game, then it's probably worth using a shader from the store. Likewise, for subtler aspects of the game like sound effects, minor models, and animations, not making these yourself can save you time to work more on the core systems of your game that players will be constantly interacting with, allowing you to make the most important parts of your game even better and more polished. Finally, at the very top of the pyramid, we have the option to roll almost no custom functionality, instead relying almost entirely on third-party packages and assets to develop the game or product. Often relying on outsourcing and volunteering, these games present a high-risk, high-reward opportunity to developers, with the approach having the potential to save millions of dollars and thousands of hours at the risk of being dunked on in Steam reviews and being labelled an asset flip. The most recent example of this strategy was a game called The Day Before, which received overwhelmingly negative reviews on Steam, saw a 75% decline in its player base within 2 days of its release, caused the studio that developed it to close another 2 days after that, and ultimately forced Steam to remove the game from sale shortly after. So hopefully this video has been helpful in regards to deciding when to rely on third-party assets, packages and services, and when to build something yourself from scratch.